Yep. No. Maybe. There we go. I can see it going. I will wait. Music's a jam though. Can you guys hear me now? No? Yeah? Okay, yes. Okay, cool. Man, Streamlabs always messing with me. I was gonna stream a little bit later at night. Good to see everybody though. How's it going, Mike? Good to see you here too. Sam, I can't believe you're up at 3:30. This is what I was saying before I realized that I wasn't, you guys couldn't hear me. But if I was up at 3:30 and worked in the morning, there's no way I'd get up. So we've got vacation in a couple days. It's Memorial Day on Monday in the US. So I have Friday off. But yeah, it's good to see everybody. I hope you're all doing well. And today I'm working for your main work. Oh, okay. Dang, dude. Too late. That is too late. Right now though, what we're going to be working on, some UE code. Cool. I've got this thing I've been working on. This is super ugly. This is what we're gonna be fixing because this is just a mess. Like, it's not working at all. But basically, I've got this thing, which is going to be our editor for doing Manum stuff, right? This is gonna be my own thing, and it's gonna be much better than what Manum is like, right? Because this is real time, so already this is like a huge step up. So much better. I can pause, go forwards, go backwards, so like I can do that. I can also use some hotkeys, which is how I'm like resetting it and stuff. But yeah, the goal though is to actually get this timeline hooked up to the visuals and to actually get a nicer looking timeline because this is atrocious. So yeah, that is what I'll be attempting to do. So very impromptu, just checking it out real quick and seeing how we do. I was gonna stream in the morning, but then I was like, really wanted to keep working on it now. So I was like, I guess I'll just work on it for now. If you guys are interested too, the way we can do that cool text animation is actually not that bad. So what I do is I do a couple of interpolations, right? So you give an animation time, and I've sort of set up this whole animation context sort of like Manum. It's kind of inspired, but it's not really. I'm doing it very differently than them because I want to be able to like take any frame in your whole video and go straight to there and just render what should be visible at that frame time. So the way I'm structuring my whole program is a little bit different because I plan on having this be real time, right? The way you use Manum right now, which this is the reason I'm doing this, by the way. I kind of talked about this in the last episode too, but like if I go and we open up recent, actually let's do a Control-Shift-N, and then right here we'll go open recent, and I will go to this guy. So right now what I have to do, and this is the whole reason I'm doing this, right? The whole reason that I'm making this is every time I want to test an animation, I have to go into here, I have to say manum-pql, so I get low quality. This is like 480p. And then I have to go scene.py, which is this, and then like say I want to do the gimbal lock visualization, which is this scene right here, right? So then I would do this, and I have to wait for it to compile. This is how long it takes, okay? This isn't that big of a scene. This is like maybe 15-20 seconds, and I have to wait 15-20 seconds just to see. I guess, yeah, and this is low. This is like 480p, so it is not that great. The latest Manum used by 3Blue1Brown seems to be real time too. He uses some mouse spin. And that's what I've noticed too, but his library isn't the same as the community library, and I've tried using it because I was thinking of that. I was like, let me just try his real quick. But his library has the same problems as this, which is you'll notice there's no 3D support whatsoever. And that's the second big reason, okay? I've been like struggling. So for all the past videos, whenever I've had to do anything with textures, whenever I've had to do anything in 3D, it's been such a pain, like such a pain just to get it to look semi-right. So I was like, okay, screw it. I'm making my own thing. I'm actually going to work on my own one. That way I'll get the editor, so I get real-time feedback. I don't have to like say, oh, I don't really like the way that's positioned or whatever, and then have to redo everything. By the way, if the music is too loud or anything, please let me know. I think I'm going to turn it off actually, because it's kind of distracting me a little bit. Maybe next time. One of these times we'll go. But yeah, so it's just really high iteration feedback, or low iteration feedback, I guess. It's really annoying to iterate on this stuff. And then 3D is just non-existent. You have to hack to get it to work anywhere near semi-correctly, and it's just annoying. Yeah, what's supposed to be happening is this circle is supposed to be around and then turning. Yeah, so And then you have to write all this code too, which is also really annoying because literally 100% of this is just configuration stuff, right? So I start off, I say, add the title. That's a configuration thing. Like there's no reason I should have to code this. And then I say title.rotate, title.rotate. This is just setting some rotations before I add it. So just more configuration stuff. And then this is the whole thing that's like the only part that's kind of like you can't code it, but even then you can, because I'm going to have these animations as literal things that you can just drag and drop onto the timeline. And it's the same deal. So this is all unnecessary, but it is good to have code sometimes. So the second phase of this whole editor thing is if that need arises, I'm going to add Lua scripting so that I can also have the full benefits of a scriptable object as well. There's no reason to, I want to use my resources to the best of my ability. And there's no reason, like this will be way faster to just iterate and work through and everything. So I'm hoping this will boost my video productivity and stuff too, and just make it feel better working through the videos. So this is what I've got so far. This editor, or this write-in animation is what I was about to take you guys through. And it's actually not as hard as I thought it was going to be. If we actually, I'll open that back up real quick. If we go through and I like play and then pause, actually that was a bad point. Here we go. So you can kind of see what it's doing. First, it just draws the outline, and then if we catch it, let's see if I can do this better with the keyboard. Wait, there we go. Okay. And then it fades in. So that fade in is kind of that second time part. That timeline looks pretty cool. Yeah, it's just, as you can see, it's totally janked up, and that's because I'm using some library. So we're going to take it for inspiration, and then I'm going to do it right, because this is all completely messed up. So and it's a work in progress in the repository too. So it's not fully supported, which is why I'm just going to redo it, and then we'll do it right. But yeah, so you can see those write-ins are just drawing the outlines, and then it fills in the interior. And so what I do is I basically just go, let's get an interpolation value, which is this T value. That ranges from 0 to 1. So what % of the letter should we draw, or however you want to interpret that. And then I interpret that as how many letters are we going to draw. So then I say, like, how many non-white space characters are there? Because we don't want to animate a space. That's just blank space that's taking up unnecessary time. We figure out how many numbers to draw just by multiplying T by the number of non-white space characters. Then we loop through. And then this is where kind of the magic happens, I guess, where we say if we're on like half a letter, so right, we're in the middle of drawing a certain letter, we basically just take like the number of letters to draw, which is a floating point value. So this is continuous. Number non-white space characters drawn. Yeah, it's a bit of a mouthful, but hey, super explicit. You know exactly what's going on there. So then we just take like that fractional portion, and that tells us how much of the percentage to draw. And then I go and I call this render write-in code point, which basically goes and does a single letter. So then I split it up. This is another T value. This T value determines how much of the actual individual glyph to draw. And it is just a glyph, because we're going to have composite glyphs and stuff once I start throwing in Manum and everything. But basically, I say like at 0.8% of the T value, once we're 0.8% of the way, start fading in. So like the last 20% of the drawing animation is also fading in animation. And then to get it to look smooth, you have to do something kind of hacky. I don't know if this is like the proper way, but basically, since like this is one curve, this straight edge on the H, but this is also one curve, if we were to simply say like, hey, let's just draw let's multiply that interpolation by the number of curves, it would go really fast over the straight line, and then, or actually really fast over the, really fast over the straight line and really slow around the curves. So it would be like inconsistent. And you can see that I have it pretty much consistent going across the whole thing. And the way to do that is I approximate the circumference of the curve, or the perimeter of the curve, right? And so basically, instead of going based off of like, let's interpolate based on how many curves we have, let's interpolate based on how much of the perimeter we should draw. And so that's basically what's going on here. I figure out how much length we've drawn, and I just loop through each of the contours. This is MVG, which is like a path rendering library. So I can basically just say, okay, let's set the stroke color. If you've ever used JavaScript HTML canvas, this is basically what this is. And then it basically just goes through. If it's a straight line, we just draw a line. So it's a NVG move to. Otherwise, if it is a Bezier curve, Then I approximate the curve length by taking the average of the chord length somewhere up here. Let's see, where is it? Oh no, I'm sorry. This is the Bezier curve. That's why I wasn't seeing it. There we go. And then what I do to get the approximate length is I basically take the chord length and I take the control net length, which is basically the length of the control points. And I just average those to get an approximate length of the Bezier curve. And then we add that to our approximate length and we basically interpolate based on all those values. So if we were to, whoops, that's not what I meant to do. If we were to look at like Bezier curve, what's that? Desmos. Yeah, there's something good on here. So basically what ends up happening, yeah, here we go. This is a good one. All the curves are four-point control curves. And so what happens is we basically just interpolate between these straight lines, right? So as I'm going, I'm basically interpolating there, interpolate that, interpolate that. And what happens is we actually get the same curve. We'll actually be able to see this a little bit better if I do it like this, right? So if I just like move, there we go. If I just move this up and around, you'll see it actually modifies the curve. Like this whole shape changes. And so you don't want that. What we want to do is we want to just travel along the curve. And so what you have to do is you actually have to like interpolate each of these. So I would move that slightly back, I would move that slightly back, and I would move that slightly back. And this would basically, if we interpolate along each of these straight lines, that just ensures that it maintains the same shape while traveling along the path. So Beziers are nice that way because to interpolate them, you just interpolate between each of the control points and it gives you this cool traveling animation. So it's pretty cool stuff. You have to do a few tricks to get this to work right. So I'm glad I looked into all this stuff prior, but in the end, it all works out and it looks pretty cool. So the timeline, how are we going to do that? Because that's not going to be fun. So the code that I pulled this from is called ImGui Gizmo, whatever that is. I think you guys have probably heard of it. It's the same thing that Cherno uses for his gizmos. And they have this thing, but it is a work in progress, as you can see, and there's lots of issues here. It works kind of for the most part, but just doesn't look good. And the interface, like implementing this thing is horrible. To actually implement it on my side, I have to do all of this stuff, which, in my opinion, this is a horrible API design because if I'm the user of this library, I should not have to like implement your draw routines, if that makes sense. So I think this is a horrible API. That's why we're going to redesign it and basically make it better. So let's start seeing how they're working with this stuff because I have an idea of how I would go about building this. I just want to see what they did, and then we'll kind of steal from their ideas and modify it to make it work right. So if I go into here, this is the final API call once you've got all that stuff out of the way. Basically call sequencer, which takes in the sequencer interface, takes in the current frame. So this API I like. Kind of. There's still some, like, this is a bit ambiguous. Expanded means like, is the selected entry expanded? That's what that means. So like I would probably swap this in front of a selected entry. And then you got this first frame thing, which is like what's the scroll position? And then these sequence options. So let's kind of go through and take a look at how they get this done. And then I'm mostly interested in how they're drawing their stuff because that's the one part of ImGui that I always kind of hate is trying to figure out how to draw stuff. Which is why I shy away from doing custom widgets. But it looks like that's going to be that's all we can do right now. So, okay. So they get the IO, CX, CY, which is the mouse's position. Why are they calling that CX and CY? I don't know. Maybe MX, MY, but... frame pixel width, target, legend width. Okay, so what is legend? I think legend is this left side thing. I think that's this stuff. moving entry, moving pose, moving part, del entry, dupe entry, item height, pop-up open. We're just gonna take a look at how they're drawing this stuff. Okay, so they get the draw list, and then I'm just gonna redo it myself. They get the cursor screen position. So this is where the draw list should start going. ImDrawList API uses screen coordinates. Okay, oh, so that's why they're getting the cursor and screen position. Gotcha. CXX and CY for cursor. Oh, cursor. That makes sense. Function's called mouse though, so I would still use M, but that does make sense. Resize canvas to what's available. So we do that. How do we actually add stuff here though? Okay, so he does this IM vector with custom draw, compact custom draws. Okay, and these custom draws are what eventually go through this, which takes in the draw list, a rectangle, a legend rectangle, and clipping rectangle, and a legend clipping rectangle. And what does this do? This. Okay, so these are the curves. Ramp edit is like those control curves. Draw list, so then we push a clip rectangle. So, okay, so I think what's happening here, I could be wrong. So I think what's happening here is they're just drawing this whole timeline, and then what they do at the end is they just clip out this left portion where the legend is, and then they just like overwrite that stuff. I think that's what they're doing. So then we push the clipping rectangle, yeah, and then they get the legend rectangle. And then they add the text. Yes. And then they pop that clip rectangle. Then we set it. And then we continue. Okay, so that's all that's doing. That's not that big of a deal. If we go back into here. So that's all these are. I don't know why he didn't implement those parts himself too. Like, it's kind of weird that that's thrust upon the user instead of just being handled by the API itself. But whatever. Okay, so then visible frame count, how many frames are visible? That makes sense. Bar width, pixels, panning view. Yeah, this timeline is not going to be a fun thing to do. That's for sure. I don't know, it will be fun. It's just it's not going to be a trivial thing, which is unfortunate. Hey, from Europe at 4 a.m. Dang, how's it going, Jalmega? Now the question is, did you just get up or have you just not gone to sleep? Okay, so we've got the invisible button. Add filled rectangle. Okay, cool. So with the draw, okay. So this actually shouldn't be that bad because we can basically just use rectangles and text. That's pretty much all this is. Right, we've just got the numbers for the frames, which I will probably convert to seconds and then frames if it's zoomed in. Does this? Yeah, see, like this doesn't even support zooming or anything too, which is unfortunate. Have time off, so still up. Gonna go to bed in probably 30 minutes. Dang, dude. I would not be able to do that. I don't like staying up too late because then in the mornings I'm just like, I don't know, makes me feel groggy the rest of the day the next day. So, okay, so this whole part looks pretty easy. I think we're going to start with like the background because the background in this kind of horizontal cursor, because this is just rectangles, right? We just have the timeline, some ticks to represent like a certain, this is frames, I guess. And he doesn't even have like arrow controls or anything too, which is pretty annoying. Whoops. Does escape close my app? I guess it does. I did not know that. So yeah, let's start with that. And I guess we can just use this type of stuff. So let's go editor. We're going to add a new thing in here called, what do we call this? We call this, I already have something called timeline though. so this is not good. Let's call this ImGui timeline.h because this is the actual GUI for it, I guess. So hash if not define, ImGui timeline. Actually, this is math anim, ImGui timeline h define that. Okay, so it could be nice if you bind animations to an input instead of following a strict timeline. Carver, thank you for following. Instead of following a strict timeline, something like PowerPoint presentation. Could be nice if you bind animations to an input instead of them following a strict timeline. Something like, oh yeah, we're totally gonna do that. If I understand you correctly. I'll kind of go through. So Resolve, DaVinci Resolve is another thing that I'm going to be pulling inspiration from. Let's do that. So in DaVinci Resolve, and this is kind of how I'm going to approach this too. We'll open this up real quick just so we can check some stuff out. This is a beefy program too, but it's a great program. This is one of the few things that I've actually shelled out money for the Pro Edition because they're good. So unintentional shilling. That was not my point. And man, at nighttime, I do not have the greatest lighting here. Okay, so in DaVinci Resolve, if I want to have some sort of animation, say like I pull one of these things over, let's see, we'll do a dip to color because this is something that has like a parameterized type thing, right? So this dips out to a color as it fades, right? If I just play this, just goes to black. But over here we have our inspector. And so then I can go and I can say, actually, I want this to fade out to an orange color. And we can do stuff like this. Now, this is good because then we can also do things where they have like, I don't know. They have these special ones. There's probably some better examples of this. But essentially what like my plan is inside of this inspector type window, it'll almost be more like a Unity thing, right? Almost more like a Unity thing than it will be like a Adobe Pro or whatever, right? Mike, I had no idea. So basically like, I don't know, where in Unity, like you can drag game objects and stuff over here. That's sort of what I plan on doing, right? We'll have our scene objects, and then we'll be able to drag like these, which are like actual things in our scene. So like say I wanted to do in Manum where they have like replacement transform, which basically morphs one object into another. So say I had one object here, I had another object here. Then what I could do is I could drag this where like you can see in DaVinci Resolve, you can actually do like a, well, I could if this wasn't the beginning of the video. You can basically, here we go. This is a good example. So this is like a fade between these two, right? And so then I can drag animations from here over to get like a fade between and kind of do transitions between different objects and stuff too. So think of it more like Unity than it would be a traditional. And I think that's what you were saying. So may have misunderstood you there, but that's kind of my plan. Anyways, though, let's think about how we'd like this to work. So what does a timeline consist of? I guess is the best thing. A timeline consists of several rows. That's not what you meant. Oh, sorry. I'm actually going to switch to the drawing screen real quick because this will be useful to draw out real quick and just sort of sketch out. No, I don't want to take a survey. Okay, so let's go over here. I have switched from OneNote. It was just not working right, and it was giving me large headaches, so I gave up on it. So this is bamboo paper, which we'll be using instead. Okay, so what does a timeline consist of? A timeline consists of several tracks, right? And this is definitely something I want to have. We're not going to have audio, so I don't have to worry about that. But we will have like a certain amount of tracks, right? And we'll have like a label here. So we have label or legend, I guess, like that one guy called it, would probably be a good idea. Let's keep some consistent terminology. So then we have like track 1, track 2, and this is how we can like overlay visuals and stuff. Track 3, then we can keep going on. And then maybe it would be useful too, where we can like manipulate tracks, where we can say like this is on Z index 0, Z index 2. And then if we have 3D objects, this would be like our first draw call batch. This would be our second draw call batch, so that we could like blend things properly too, which would be pretty cool. So, and I see that box riffs. I'll talk about that in a minute too. Then the next big piece we have is this half of the timeline, right? And this is the timeline itself. And so this has your marker, right? This is our cursor. I don't know what else you would call it, right? And then we have like our tracks extending out here. So what data do we have to pass to our timeline? We have to pass these tracks. So one useful thing that we could do is have the number of tracks, right? And the track names. So what do we put here? So that's one useful thing. But then what goes over here on each track itself? And so that's where it gets a little bit trickier, I guess. Because this will, I'm wondering how we want to organize this. Maybe what we'll do is we'll have like some sort of track data structure, right? And this track contains a list of just like timeline pieces, right? Because we don't really need to know what's contained within these. We just need to order them and then give those orders back. So I'm trying to think like break down exactly what stuff we'll need. So this track will basically look like bracket, close bracket. We'll have a list of, what are these called? These are animation bars. I don't know. These are segments. Okay, that's a good name. So it will have a list of segments. Okay. And this will just be our segments. And now what is a segment? Well, a segment just consists of, we have a start position, right? So that's pretty easy. Float frame start. And we have a duration, which is the length of this. Float duration. And then what we can do is, as we grow this utility, we can add more stuff. So like we can add, track combinations and all that stuff where we add things to each other. But for now, what I want to work on is just like the base functionality, get the timeline up, and then have it so that we can like drag the cursor back and forth, zoom in and out, snap things together, all that good stuff. So at the end of the day, that's all we're going to have in that data. And then we can probably like have a void pointer or something just to get special data attached to each segment if we choose to. Okay. So let's kind of mock that out. And now Voxriffs. You said, I meant since an animation has several self.wait some weird amount of seconds, instead you could do something like self.wait for space. Self.wait for space. I do like the idea of like if an object is in the scene, having it actually appear on the timeline. So I think what you're saying, Twitch interprets self.wait as a URL link. Doesn't go anywhere though. Like I think what you're saying, Voxriffs, and you can correct me if I'm wrong, is basically like we could have this be like the write-in animation, right? And then I don't think I can actually drag these between. But then say like there'd just be like a gap here, and then this would be like the write-out animation instead of having this just like extend all the way to the length of what it is. And I think I kind of like the idea of having this actually extend the full length of when it's appearing on the screen, just because that makes sense to me to have like, that way when I go here, I can like quickly see and be like, oh, these are the objects that are on the scene all at once. And then we'll of course have like scriptable objects, which can be composite objects and stuff. And we'll have animation groups and all that stuff, which can contain like, you can expand that and hopefully do more with that. But for now, we will have a track. And I guess technically this will have a list of tracks. Oh, and this is, wait, what am I doing? I am in the wrong file. I was so confused for a second. This is where we want to be. Okay. Nope, not that either. I guess I'm being unclear. It's all good. Like making it a slideshow animation thing where you click the mouse to advance the presentation. This exactly. Oh, I see what you're saying. Yeah. So basically I could have it like have some sort of node in here that's like pauses it, and then once I click again inside the scene, it'll automatically continue. That could be interesting. Yeah. Yeah, I'm just kind of thinking that through. That could be interesting. I'll have to think about those types of things to see how I might go about doing stuff like that. But okay, so this will be have like a segment star segments, int number segments, and we will have a struct segment, right? And this will have a frame start, and I guess we'll keep these as ints. Let's just do a quick calculation real quick too. So this is 60 frames per second. I highly doubt we'll have to go higher than that for any sort of output videos. 60 frames per second. 32-bit int has that much numbers. Divided by 2, since we're using a signed integer. Divided by 60. So that's how many seconds we have. I'm just making sure an int is big enough to capture all this data. So that's how many seconds. How many minutes is that? Yeah, we're fine. Okay, yeah. That's like 432 days. I did 23 instead of 24. Yeah, okay. So one int should be able to store enough frames for 432 days worth of video. I think we're more than fine with 32 bits for representing frames. Okay, so we got that int frame duration, and then we can do our conversions from frames to seconds, all that stuff. Okay, so we've got that. We've got our segments. And how do we want to pass these back and forth? Because then the next thing is, I guess we will have something like, I don't know if we want this. We probably want to do this like out here. So I'll have like void ImGui timeline, and this will take in, why is this mad? Oh, I am missing a semicolon. I was like, why is that red? Okay, so we're gonna take in a track double star, right? No, we just need a track star. So we need an array of tracks. We need number of tracks. Should I do this ImGui style with the, what is this, snake case? Nah, we could do this my style. Okay, so we're gonna have tracks, we have the number of tracks, and then I guess we could have flags, because all ImGui stuff have flags, right? And then we can eventually add more flags to this if we want. Timeline flags underscore. I guess we'll just call that flags, and then we'll do flags. ImGui timeline flags. And we will have none. Why can't we do that? Because I need core. Okay, so we call ImGui timeline. We just give it our tracks, and we give it the number of tracks. Now we need to propagate those changes back out somehow, right? Yeah, what we also need to do is we need to pass in like cursor frame. Right, so this is the frame that the cursor is currently on, right? I'm kind of stealing this from their stuff right here. Yeah, so we'll need that current frame. We will need the first frame too for now, and then we can add more stuff as we get more capabilities. So we'll have that cursor frame and then int star first frame. I like this as current frame instead better. Okay, current frame. Do we even need the first frame though too is what I'm wondering. Yeah, that does make sense because depending on where, yeah, okay, that makes sense to me. Cool, so then scroll will alter this and clicking and dragging will alter this, or like right and left arrow or something like that. And then I guess we could do bool to be really ImGui style, and we'll return a bool if something changes. You know what? I really want to see a reaction to this one. Differences between procedural and object-oriented programming. Just got sent it in memes and media. Uh-oh. Is based on the Unreal world. I like that it's actually between procedural too, because yeah. Procedural programming can be defined as programming model which is derived from structured programming based upon the concept of calling procedure. Procedures, also known as routines, subroutines, or functions, simply consist of a series of computational steps to be carried out during a program's execution. Yup. I know some people don't even consider like C procedural. Check the table, it's worse. Uh-oh. The program is divided into small parts called functions. Yeah, like I think some people would argue about even this and say if it has functions, it's not actually procedural. But anyways, object-oriented program, the program is divided into small parts called objects. Yep. Top-down approach, bottom-up approach. I think these are flipped for sure, because typically with object-oriented programming, you're thinking about high in the sky, whatever objects. With procedural, you're thinking about the data, so I would flip those. There's no access specifier in procedural programming. Object-oriented programming has access specifiers like private, public, protected, etc. True, but you can mock access just by actually hiding stuff like in C. Adding new data and functions is not easy. Well, that's not true. Adding new data and function is easy. Okay, I think this is what you were getting at. I don't know how you come to that conclusion. Procedural programming does not have any proper way of hiding data, so it's less secure. That is not why people say procedural programming is less secure. And it does have proper ways of hiding the data. So yeah, GLFW is a great example of that. You have no idea what they treat their pointers like. All you know is you have a pointer, but you don't know how they do stuff. Overloading is not possible. Also not true. Overloading is possible. Procedural programming, there's no concept of data hiding and inheritance. That is also not true. You can do that type of stuff using pointers and whatever. Concept of data hiding. The function is more important than the data. What? How do you get this? The data is more important than the function. Now this I would definitely argue with. C++, hash define private public. Yeah, I mean C++ actually has private public and stuff too, but Oh, I see what you did there. That works. But procedural programming is based on the Unreal world. Huh. On the real world. Okay, then. Is designing medium-sized programmings. I would call Windows operating system and kernel a very large program. Uses the concept of procedure abstraction. Using concept of data abstraction. Yeah, this is not true. This object-oriented uses the concept of object abstraction, where you treat everything like an object, and then you get screwed over because you're like, now what the heck do I call this factory, builder for my whatever? But yeah, no comments. Pankaj, I don't know how to pronounce that. I'm sorry. Not a very good article. I don't know. I see some stuff that is quite interesting, though, in like the differences and stuff. Oh, yes. A recipe is clearly an object, right? Yeah. That's good, though. I appreciate the laugh, Oxorus. Okay, let's go through. So, ImGui timeline. I want to draw this thing. And hopefully it will be pretty easy. So, let's go ahead. We will say... Snoo Studios. Hey, leave my factory, builder alone. I'm sorry, no hate here. If you like object-oriented programming, that's fine with me. Used it for a long time myself. So let's see. What did I call this thing? ImGui timeline. I'm not typing. ImGui timeline.cpp. Alrighty. Also, if you guys want a great satire article on that type of stuff, I think I have it saved because I really liked it. Let's see. Somewhere in here. One of these. Code stuff? It's probably code stuff. Yeah, here we go. Hammer factories. This is great. For your pleasure and your own time. But it's kind of a rip on factories and stuff. But it is funny, I think. I don't know. To be honest, the definition of OP does not require inheritance if you associate data and functionality. That's OOP in my view. Yeah, the problem with OOP in general is everyone's definition of it is different. And so you run into that thing like the no true Scotsman fallacy. Every time you try and criticize any specific portion of it, they'll come back at you and say, well, you don't really understand OOP, which is like, I think the no true Scotsman fallacy is like any true Scotsman would never put sugar in their tea or something like that. But it's basically what I've come to realize. And there's a lot of things like that. When you find yourself arguing with somebody and what did I call this? Math anim. A lot of times you'll come to a point where it's like, that's their argument is if you truly understood. And if they ever start saying that, then it's usually time to back up. Sometimes you truly don't understand. Like, that's totally legit. But a lot of the times it devolves into that because some people don't like accepting criticism, which I get too. I don't like taking criticism either. So, okay. So we've got our tracks. We've got the number of tracks. We've got the current frame, first frame, flags. That sums up a lot of arguments I've had before. Yeah. I've learned a long time ago. There are certain people that you can debate, and there are other people where a debate is just useless because no matter what you say, they're not going to listen to anything. And so with those people, I found it's best just to not waste any time. And you can usually tell like if a person's like that pretty soon. And so instead of wasting my time trying to argue with somebody who doesn't want to listen, you can go and debate somebody and actually learn some stuff if they want to criticize you, and you can criticize them and hopefully get some good back and forth, which is fun. I've got some good friends like that, and we have some great discussions. So find yourself some friends like that because it's great. Sometimes it's not so great. Okay, we are going to have some internal functions. I am doing data hiding in a procedural language. These functions are not visible to anyone but anyone in here. Semcheck, I don't know. I like to code OP stuff. Yeah, and I think everything has its time and place. I tried to go too far the other direction, I think, and OP definitely does have some good qualities about it. But, okay, so the one thing that I think OP, this is a tangent, and that's fine. This is kind of why I did this, because I wanted to go on tangents and stuff. But currently using Rust, I'd call that OP. Yeah. I don't know Rust too much, so I can't speak on that. But the one reason that I thought OP was good for the longest time was strings, okay? Because every time I go to try and do a string, right? Say you have a char star, some string in C++, right? And it's this. And then you have another char star that's coming in as input, right? You don't know what this is. Concatenate this, right? So you want to concatenate this guy with this guy. And it's so annoying because what you have to do is you have to do something like, okay, let's go. Well, I guess, okay, so first of all, you'd have to say size t, string 1 length equals string length, concatenate me, right? So we get the length of that, size t, string 2 length equals string length, str, right? And then we go and we say, okay, let's combine those. So then we, size t, output string length equals string 1 length plus string 2 length. Then we allocate some memory, and this is where it starts getting tricky. So then it's like, allocating the memory and stuff, concatenate me. Yeah, I spelled that wrong. Isn't terminated. Then star. Yeah, if it's not null terminate, that's also bad news. But basically the point is, this isn't too bad and stuff. The bad part is when you start getting into like output string equals memory allocate, right? And so then we have to start doing this. And that's fine too. But then once you get to things like, I think in my CPP utils, I had this. I was trying to do this and I just gave up because it was so annoying. Let's go to glogger assert underscore F3. Let's go down here. Is this the one I want? No. Let's go back up. Yeah, I think this is the one I want. Okay, yeah. So this is basically the one thing that made me say, you know what, strings aren't so bad. So basically what I'm doing here is I have a bunch of input strings, right? And I tried to do this the C way and I gave up. I was like, screw it, I'm just using strings. So we have a file name, that's an input string. We have a format, so then we're going to be doing some printing into some temporary buffers and stuff, right? So basically you have to do like this whole critical assertion failure thing, print out the line. We have to concatenate all this stuff. which is annoying. And I saw the other day on Zoding Daily, which I don't know why I never thought of this. It was either Zoding Daily or I was reading an article about scratch memory. And I've heard of this before, but I don't know why I never, it never just clicked for me. To make this easier, what you could do is you could say char star scratch equals temp alloc, and then you just allocate like 512 bytes, right? Just a ton of memory. I mean, you would still make sure you don't overdo it or anything. And then after you finish doing all your concatenation and stuff, all you would do is you would say, I guess we would do like push alloc, right? Push scratch alloc or something like that. And then what we do is we just say pop alloc, right? So then we would allocate our final memory at the end of this, which is our permanent memory. And then we would just pop all that and that would just reset back to, and I've heard of this, but it just never really clicked for me. Let me undo all that stuff. So anyways, I know Voxrofs, you sent me an article a while back with memory arenas and stuff. And yeah, so that, long story short, OOP I thought was good for strings and short-lived stuff like that. But the more I thought about it, the more I was like, it's actually not that bad to just get some sort of scratch memory like that and then give the strings life ownership to one person directly and then sort of free it. The ownership thing is where it gets a little bit trickier and stuff too. Voxrofs, this is exactly why I set up my own memory allocator and string library. It makes stuff so much better. Yep. And then when you use string length, you have to look up if it includes an ultimate and the count. Yep. Even though you've used the function before. Yep. Exactly. I think the pointer length strings are so much better than null term. Yeah. That's why I set up in my memory system an mscratch object, which I can request per block, which makes using strings in C so much better. Yeah, it really is. And so there's a lot of niceties like that you can add that I just never took the time to learn about. Kind of reminds me of that thing that Casey Muratori was talking about too, where it was like most programmers will get to a point where it's like they never jump from, oh, I have to allocate memory for every single object to, oh, let's allocate a big block of memory for a group of objects. And I don't know. I might have sent that to you guys or not. I'm not sure. I was just watching some Handmade Hero or something and saw that, and it was just a good explanation. But anyways, okay. So we have our tracks, we have the number of tracks, we have our current frame, we have our first frame. So how do we want to render this? Looking at my Scratch stuff, each track is going to have a name. And I guess that brings up a good question too. Do we do a char star for each of the tracks' names? Probably going to be the easiest thing, honestly. I may change my mind on this later, but I think that should be fine. We'll do a char star there. And then whoever passes that, it is in charge of the ownership of that string and everything. I'm not going to worry about that. Okay, so I guess the first thing that we want to do is something like what they did here, which is we want to get these things. Yep, and let's go ahead and we'll include ImGui, internal. Let's also do that because that will be nice. Oh, operator overloading is another thing in C though. That's super annoying. See you, Hilbert Curve. Thank you for watching the stream. It was good to see you. Yeah, C doesn't have operator overloading, which I don't know. I always go back and forth on that. Okay, so anyways, we've got our draw list, we've got our canvas position, we've got our canvas size. So we've got that in screen coordinates. We've got, okay, so that's basically all we need, right? And now the simplest thing we can do is we can just go for our current frame. Yeah, let's just do the simplest. Okay, so we'll say like float percent legend percent. I'm not sure how I want to do this. ImGui has like tables, right? Yes. This might be good. Let's go real quickly. I have the demo window up. We're going to check this stuff out because I think I have a specific idea of how I want to do this, and we're just going to see how to make that a reality. And now I got to wait for it to recompile everything. Okay, in the next half hour, I just want to have a rectangle up on the screen with each frame drawn and the numbers for each certain segmentation of ticks or something like that, or frames, I guess. Okay, must return a value. Return false. C++ compilation is so much slower than C, too. I have noticed whenever this compiles C files, it goes way faster. Okay, so let's pop open the demo window and widgets, tables. I think what I want to look at is that. I think. Yeah. So I guess that would be under layout and scrolling. No. Pop-ups, modal windows, tables, and columns. This is what we want. Okay. So if we go to basic, yeah, we've got this. It kind of segments everything off. Borders, background. Ooh, yeah, we've got the borders, backgrounds. That's also good. Resizable stretch. This is what I want. Yes. Okay. So I want to be able to do that. This is what I was looking for. If we turn on borders, V, yeah, resizable. So basically we'll have our legend over here, and then each row will be a track. So this will kind of all just fit together perfectly. And then each column, we'll have one, I think we'll just have 2 columns. And then inside of the second column, we'll just have like rectangles that we draw. So let's try that first. Let's pop that back over there. So this is going to be that second part so that we can drag it and make it bigger or smaller. And each row, I'm also going to allow you to make it bigger or smaller. Pretty sure I posted this on Discord before, but if you want to use C or even C++, you should have a base layer. This is particular series is amazing in my opinion. Let's check it out. Helper macros, base and compound type, symbolic linked lists, memory management, strings, Unicode. Yeah, that's another thing that's just, I'll have to check this out. But that is another thing that's just annoying to me in C is like no generics for things like data structures. Like I know you can do it with macros or you can do it with void pointers and stuff, but it's just, that's the one thing that I'm annoyed. So I think what I'm going to do in the future is I'm going to convert like my libraries to C APIs, and then I'll use C++ internally. That way it should like hook into any other C code, and it should compile and have like no name mangling or anything like that. So I think that's like a cool mix to have, but that's for a future time. What we want to do though is we want to say like ImGui. How do we even use tables? Begin table. Nah, table. Okay, so we have table begin apply request, table begin cell, table begin row, table draw borders, get current table, begin table. I guess we do have this. So tables, full feature replacement for old columns API. See demo tables for demo code. The typical flow is call begin table early out if returning false. Optionally call table setup column to submit column names, flag defaults. Okay, cool. We don't need column names. Actually set up call table scroll freeze to request scroll freezing. That's not necessary. Headers row to submit a header row. Populate contents. Okay, so our cool table. Column 0. Flags. Resizable. Yeah. We'll say if this. Okay, and I guess ImGui begin row. Get current table. Okay, cool. So we can begin row with the current table, and I guess we could say like if. Wait, does this not? No, that's void. Okay. And then we would say like ImGui end table row. We would indeed. Okay. ImGui get current table. See, I'm wondering if I want to do this though. I don't think I do. I think I just want to customly draw all this stuff myself. I don't know if that's good or bad, but I think it'll be easier. I actually have a data structure macro file already used a lot nowadays. Nice. If you don't mind, I might take a look at that later. Maybe you could paste it in Discord or something, like helpful resources. So I could take a look at that because that'd be cool. Okay, so I've gone back and forth all here. Let's just do the legend real quick. So legend width equals 0.2 f. Okay, so we'll start it off at 0.2. It's gonna be static. Sam, you can easily draw this with Nano VG, but you'll lose all of the click input stuff. Yeah, and that's what I know too. I do want to keep this all in ImGui. It's not the drawing that I'm concerned with too much. It's just like how I'm gonna manage all this state, because there's a lot of state here. And so yeah, let's do this. So we have our legend width, which I'm gonna set to 0.2, and then you can click and drag to resize it. We'll do the legend as a different color. Color background. Highlights. Oh, it's just BG for backgrounds. Okay, where is our backgrounds? Frame background active hovered. Okay, so we'll do frame BG that. I want to get ImGui IO. This is a ref. GUI style ref style equals io.style. No, ImGui get style. There we go. Okay. Style.colors. What does that give us? That gives us an ImVec4. Okay, this is our light color. Cool. Or I guess we could call it legend background. Sure, sent it. Cool. Thanks, Foxref. Might check that out later. Okay, and then we're gonna do is we're gonna say draw list, add rect filled, pmin is gonna be our canvas position, pmax is gonna be our canvas position plus canvas. ImVec2 legend size equals canvas size.x times legend width and canvas size.y. And we're going to do that. Okay, so that's our legend size, and then we can just do legend size. Let's just change this stuff up. Okay, so we got that. Canvas size. Canvas pose. Draw list. Canvas size. Okay, so we do that. And our color is just going to be ImGui color. ImGui color. One of these things, I know. ImColor U32. Wait, okay, ImColor. What do we have here? No, we don't. Okay, there's some way to do this in ImGui. Let's go ImColor. Push style color overhead might. That's not what I want. Yeah, so we can pass in RGBA or an ImVec4. This is interesting too. He's got it as a const expr constructor. I think that's what this is. I didn't even know you could do that. Cool. Okay, well, yeah, so I should be able to just do ImColor – legend background. Okay. And then we've got our rounding, we've got our flex. Okay, let's do that. Cool. So this is our first thing. Amazing, I know, right? So let's go ahead. We're gonna go into our timeline and we're gonna go ahead and just pop that out. And instead, we are gonna say include editor timeline. No, editor ImGui timeline. Okay. ImGui timeline. There we go. Tracks. We're gonna pass null pointer for now. 0. Actually, current frame. First frame. And flags. There we go. Okay, cool. Last time I used it was for following the C++ Vulkan tutorial.com and C. So it's got a dynamic array, set, hash table, and stack. Nice. So with hash tables, I always implement some sort of insertion routine, and I never get around to the deletion routine, which is not a good habit to get into because deleting is just as important as inserting. Cool. So that's working. You can see I've got this blue thing, and I didn't intend for this to be blue, but I think I kind of like that. Yeah, I kind of do like that. So we got this blue thing. Maybe I'll change it in the future. What I want next is I want to be able to like click when I hover over this. It should change to a horizontal cursor, which you guys can't see. And I should be able to click and drag and maybe like highlight a line. So this is our first very small piece of state that I should be able to add. So what we'll do is we'll try to encapsulate all this state stuff pretty easily. So we can say static bool is hovering over legend split. The hash table is literally generified from crafting interpreting. So yeah, it's got it all. Nice, cool. Yeah, that was a interesting hash table implementation. I remember with the tombstones and all that stuff. That's all I remember from that implementation is tombstones. I think we can actually use ImGui. It's got some internal stuff to help out with this. ImGui internal. No, ImGui hover rect. I think we can do that. Yeah, is mouse hovering rect. Cool. So this is great. Like we can do this type of stuff. And what we'll do is we'll have like a, so ImGui's got all these helpers, which we will be able to use. Sam, ImGui is last item hovered. That's true too, but this isn't actually gonna be an item. I just want to check and see if we're hovering over like a certain area. So this is kind of like a little bit different because I don't want to just hover over the whole thing. It's just that little split in between. And so what we can do is we can say like ImVec2 pixel gap or whatever. I don't know. Split width. We'll call this our splitter. Splitter width equals like 4 pixels, right? And I guess this is just a float. It really, yeah. So then we can say ImVec2 splitter begin equals our canvas pose. Or actually, I guess we could do our legend pose. Splitter begin equals legend position. Where's our legend position? I swear I have that. Oh, I guess that's just canvas pose plus legend size. That's what I want. Canvas pose plus legend size minus ImVec2 splitter width over 2, 0. Okay, and then you can use internal ImGui split. I used it too. Oh, cool. Split. Splitter behavior, rect, ID, axis, size 1, size 2. That looks pretty intense. Splitter behavior. Yeah, this is probably the way to go, but this looks pretty intense. I'm not sure what all this stuff does. Maybe I'll look at that. If you have some links or whatever, you can send me, maybe over Discord or something. I can take a look at some point. But I'm going for simple, keep it simple, stupid right now because I'm stupid and I need simple. So our min is going to be our splitter begin. Our max is going to be our splitter begin. It's easy. I'll send you an example. Okay, cool. Plus ImVec2 splitter width and canvas size.y. Yeah, so that's all we need is it hovering over this rectangle? If it is, then we want to, first of all, draw a little highlight. So we'll say draw list add rect filled. We will go pmin is going to be, once again, splitter begin plus imvec2 canvas size.y. Okay. And our color, yeah, splitter background color, which we can say imvec4. And I guess I'll do a reference there since I did that last time. Style.colors. Oh, equals style.colors. I was wondering why IntelliSense wasn't going there. ImGui call frame BG. And I guess we need to do ImColor around that. Cool. So we draw that rectangle, and then we also want to say like ImGui, I guess io.mouse. Set mouse mouse style, or maybe cursor. Mouse draw cursor. What do we want to do here? Because I want to basically just switch to the horizontal cursor thing, which I know it has because it did that. Just don't know how it does it. It's got a lot of stuff in here. Oh, cool. They've got a lot of cool inputs too. I just looked at my code and I use ImGui tables for the splitter. Yeah. See, and that's what I was thinking too, but I don't want the tables because I feel like that's just a little, I don't know. It's just more than I need really. You can basically create two tables and then the parent will have the two columns. Yeah. I'm going to have a lot of custom behavior though. So I feel like it's easiest if I just kind of go this way, but it's not that hard. So I am fine with this. Draw cursor. I feel like this is what I want. Mouse draw cursor. Request ImGui to draw a mouse cursor for you. If you are, oh, no, that's not what I want. Okay, let's Google this real quick. ImGui set mouse cursor. I spelled that wrong. There we go, mouse cursor types. That's done. The hardest part was embedding this. Yeah, okay, so where's ImGui set mouse cursor? I was looking for that. Do I just... Oh, I don't even need IO. That makes sense. Okay, mouse cursor, and we want horizontal arrow. Not arrow, okay, let's see. Resize east-west. That's what we want. Okay. So that should at least, let's see if that works. We should see it hover. When we hover over it, it should give us a blue line. And we're not getting a blue line. That's already a bad start. Oh, wait. Was that just because I was hovering over my window? No, okay. So when I hover down here, my cursor's changing. You guys can't see that. So I think I have it just wrong. Wait a second. Splitter begin. Splitter begin is canvas pose plus, that's why. We need canvas pose plus that. Yeah. Okay. So I was just setting it to the bottom right corner instead of setting it to the whole canvas. There we go. Okay, yeah. You can probably very faintly see that when it switches colors there, when I hover over it. That tolerance is a little bit too low. I think we should... 4 pixels is good for like the render width. Call that render width, and then we will have float splitter width equals like 12 pixels. And I guess we can do that and put that there. And let's just make these const exprs since they are magic numbers, and that's all they do. So this will be minus that. We use this for rendering, so we do that. That. Okay, and I need a brighter color. ImGui frame background. Oh, I use the same color. That's why. ImGui color frame background active. I thought I used that. Did I use that? Let's use hover instead of active. ImGui color frame background hovered. Okay, let's try that out and see if that's a little bit more visible. And then I want to do it when you click it. I should be able to drag it left and right. There we go. That's way more visible. Cool. So then we need to like track the state. So if we're clicking it, we should be able to drag right and left to make it bigger or smaller. That should be basically pretty easy. And this is getting big. Let's add this into its own thing. So static bool handle splitter. Handle legend splitter. Right? And I'd like to put most of this logic in here if we can. So we will have this in here. And we need the canvas position. Yeah, we can make that const. So ImVec2 canvas pose legend size. Yeah, and I think that's it. I guess we can just pass in the style. Oh, and we also need the canvas size. So const ImVec2 canvas size. Okay. We can make that const guy. Cool. Let's not pass this through because I don't feel like making that grow to an unmanageable thing. We'll just grab that and we will grab the draw list, which is this guy. Okay, so we got our draw list, we've got that. And then we can just do that. And then we can just say if handle legend splitter canvas pose canvas size legend size, we'll just return false. Because if we've handled the canvas cursor, well, actually, I guess we need to draw everything else. So I can't really just do that. But we haven't changed anything meaningful. So what I can do is I can say like, well, I guess this might change like the first frame start. No, I don't think it should. Okay. Who knows what this will do. But I guess what we'll have is like our result, which equals false. Result, right? Okay. So this will just do nothing, I guess. Maybe it'll do something. Who knows? For now, this is how it is. Anyways, though, if we did this, we did not actually do anything yet. We don't know. So we can say static bool is hovering equals false. Hovering equals true. False. Okay. If we click, mouse clicked. Right, okay, so if we clicked, do I have the IO? No, I don't. Okay, it doesn't matter. Then we want to say static bool is clicked, or I guess is active. We don't actually want, we just want to check if the mouse is down. Can we do mouse drag? See, this is where it might be good to have some of ImGui stuff, but it's fine. I don't know. Okay, so we'll say if mouse down is active equals true. Okay. If is active and we're dragging, well, is active and ImGui get IO dot mouse down. So if we're active and the mouse is still down, we want to drag this left or right. Yes, and this is where we want to say float star position legend. What did I call this up here? Legend width. Okay, this is where we want to alter this. And we'll do the same thing here. Float star legend width. Okay. Oh. So if we pull the mouse to the right, we want it to get bigger, smaller. It's easy. Just noticed that's almost 5 a.m. So bedtime for me. See ya. See ya, Jamaica. Good to see ya. Okay, get io dot mouse. I guess we can do delta. Mouse delta. Thank you. Dot x. Okay, that's what we want. So drag distance. Is that is active. We also want to track static ImVec2 mouse drag start equals ImVec2 start equals get io dot mouse position. Okay, so we set it to that. When we start dragging, we get the drag distance. Oh, I guess we don't even need the drag start too, do we? No, we do. Okay. Yeah. So we get the, so then this would be like ImVec2 new splitter position would equal our mouse's position. Wait a second. Wait a second. Yeah, I'm overcomplicating this. I don't think I need that. I think all I need to do is say star legend width plus equals drag distance over canvas size dot x. Okay, and then else if is active and ImGui if it's not being held down, we say is active equals false. I guess we could return is active. Let's see if this works. I'm probably still overcomplicating this, but oh, okay. It's dragging, but I never clicked, so it's kind of working. But we have our active thing going down. So this should only go if the mouse is down. Oh, if this is an array. If mouse down, ImGui mouse button left. That would be helpful. Okay. Yeah. Make sure you know what you're using here. Okay, so that's an array. There we go. So now, if I go, okay, cool. If I click outside, it doesn't work, but if I click here, it does work. We can drag this and kind of resize that stuff. So that's the first step done. Yeah, do we want, oh, yeah, that's bad. It's over here now somewhere. I've lost it. So we need to like have a minimum width type thing, right? We can't go past, I guess we'll have our min width be 0.2. So that sounds good to me. Yeah, we'll do a star legend width equals max 0.2f legend width, right? And that should give us, we should stop at that 0.2 mark. So 20% is the minimum it can go. So yeah, I can't drag left. I can drag right though, so I can go there. And we also don't want to go past like 80%, I guess. So we'll say, actually we can just do this easier. We can say min that 80%. So we can go 20%, 80%, but that's the maximum. And that is our splitter done. Yeah. Okay, cool. So first portion done. That wasn't so bad. Okay. Now we need those frames. So I need a bunch of gray rectangles going over here, indicating some unit of time. And I guess we need like some sort of zoom level and stuff too. This wasn't too bad though. This was pretty good. Okay, so let's go. We need a zoom scale. First of all, zoom factor, zoom scale. I don't know what we call that. Yeah, and we also need to pass that in here too, don't we? We do. So, right here. We'll go have float zoom. This will equal ImGui timeline flags, none by default. Not nonce, none. Okay. Oh, float star zoom equals 1.0. We can't do that. How does he handle stuff like this, where you want to pass in something that can be changed, but you want to give it a default value? I guess we just, that's a stupid question. Just pass in null pointer. If it's null pointer, that is the default value, and we'll just use 1. Okay. So we've got that. Okay. And okay, we can say float zoom level equals actually we can say float star zoom. Yeah, let's do that. We'll say like in zoom right here. And then this will be our zoom equals in zoom is null pointer address. That's not how you do that. Is null pointer. We'll take in the address of our default zoom. Otherwise, we'll take in our in zoom. Okay, and then we'll have a static float default zoom, which equals 1. That way, if they don't pass in a zoom level, we can still like do zooming in and out of the timeline. But if you do have a zoom level that you want to pass in that gets modified through multiple different avenues, we can do that too. So yes, and I have thoughts on why there's specific reasons for that stuff. So we'll do this for our zoom. We'll assume that it's 1 by default. And I guess what we can do is we can just say like for int I equals 0 until I is, well, okay. So we have our start frame and we have our end frame. We want to divide that up into, let's say, 12 gray squares. 12 gray squares max. Let's do that first, okay? So we can say float max highlighted squares equals 0 equals 12, okay? And then we can do float, this is a const expr. Number highlighted squares equals whatever it is up here, our legend width. That minus our legend width times max highlighted squares. So that's how many we actually have. And actually, I think I want to do this as an int. This will be an int, and we will do glm seal. And we'll do a float there. And we need at least 2. Okay. Oh, and then we want to cast that to an int. No. We want to cast that to an int. There we go. Okay. So then what we'll do is we'll say to timeline start equals Dark Rogue. Wow, evening stream, Gabe. That's not like you. Yeah, it's not. I decided to, because I still wanted to work on this. So here we are working on this. Not making, I mean, I'm making good progress so far. I think I'll probably make better progress in the morning, but still good. Let's do, that's the, right now what we're working on is a timeline editor thing for my animation editor thing. So I'll take a look at it in a second when we go test this out. Position plus canvas size.x 0. Right, so that's our timeline start. Canvas pose. Okay, so that's our timeline start. Editor thing, yeah, basically. Okay, so we want to go from our timeline start. We want to go int I equals 0 until I is less than the number highlighted squares I plus plus. Okay. And we can say like float square width equals number of highlighted squares over how much space we have left, which is our canvas size dot x times 1 minus our legend width. Okay. So that's how much we get for each one. Yeah, just double checking. Okay, cool. So that should be good. And then what we want to do is we want to say draw list, add rect filled, and we want to do alternating grays. Grays with like whatever the other color is. So I guess actually we want to do like plus equals 2, and we only want to draw every other square. So then what we could do is we could say ImVec2 rect start equals timeline start plus 2 square width, and this isn't a square. That's not a good name for this. So square width times I, cast that to a float, 0. So rect start, and then we want to do ImVec2 square width and canvas size dot y. It's our size, and then our color is going to be our gray color. That's what we'll call it. Okay, and then we can say color gray color equals color 32 RGBA. Is that right? What should that be? That should be U32. Okay, and then we can do this RGBA. We'll just do like 40, 40. Actually, I want to do that brighter. We'll do like a 80, 80, 80, 255. Okay. So that should draw a square every other square thing, hopefully. We'll see if this actually works. It doesn't like this. We cannot do that anymore, but that's fine. Okay. Okay, the squares are up here for some reason. They're not going down. So that's all broken. This is what we're working on though, Dark Rogue and anyone else who has just joined. Yeah, so you can see that what I've got here is just like, this is eventually going to be an editor, trying to get a timeline working down here so that I can actually add different text things to this. This is like, I can go forwards, I can go backwards. It's frame independent, right? I just give it a frame and then it renders what that frame should be seeing. And I'm basically creating a replacement for Manum. That's what this is all about. So that my video productivity will hopefully go up. That is the plan. But plans usually don't work out the way you think they will. So I will probably be very inefficient for a while while I'm finishing this up. And then I'll start boosting my productivity with videos, hopefully. What am I doing wrong here though? So timeline start is obviously wrong. Canvas position plus, we're doing canvas position plus canvas size. No, we should be doing canvas position plus legend size dot x. First of all, see what that does. Okay, so still wrong. Legend size. We have legend size is canvas size times that. Yep, that's all right. Canvas position size background. Okay. Then we have start is the timeline start, which is the canvas position plus the legend size is x plus 0. It's just weird that that's drawing in the wrong place in the y direction because we're adding 0 there. So does this get modified? No. That's const. Yeah. Okay. Timeline start plus ImVec2 square width 0. That's the rect start. Pmin, Pmax. Oh, Pmin, Pmax. That's what we should be doing. It's just drawing all the squares back to that position. Okay, cool. So we see nothing now. That's not good. We should be seeing like gray squares on and off over here. So I'm doing something else wrong, clearly. Timeline start, canvas position plus the legend size. That's correct. That looks correct. Square width, canvas size.y. Replacement for manum, the legend. Nice, thanks. And like I said at the beginning of the stream, it's nothing against manum. It's great. It's just the 3D support is horrible, and I really need good 3D support. So we're just doing it ourselves. It's easier that way. If I had a timeline, it would be very easy. The code wasn't that bad. I already have the code working, as you guys could see, but I don't want to have to code all the stuff, which is very annoying. Yeah, get it. What's going on here, though? Let's hit a breakpoint in here, because we should see this, I would think. Okay, so let's see. Our legend is... I keep thinking of, what's his name? Absolute Legends. I can't think of his name. I've been planning on doing something like that for 2 years, but just planning. Yeah, I don't blame you. Planning is hard. So we've got our canvas size, which is that. Timeline start. Oh, is this taking it in like... No. Okay, canvas pose. It says it's using screen coordinates here. But these don't look like screen coordinates to me. Yeah, like this definitely doesn't look like screen coordinates. But it is working. This is just throwing off my whole intuition because now I'm like, okay, how does this actually work? Square width is 0.05. That doesn't sound right at all. So apparently we have 2 highlighted squares. That doesn't sound right either. We should have 12. What does this give us? 80% of 12. Yeah, 9.6. Float, and I'm casting that here though. Oh, whoops, that should be max. So that's the first problem. Weren't drawing enough rectangles there. Still not seeing it though. Okay, so 10, that sounds right. 80% of 12 is 10. That does sound correct. Square width still sounds wrong though. Number of highlighted squares over the canvas size times 1 minus legend width. What does this give us? So 80% of the canvas width, which is like, okay, that looks much more correct. Yeah, 1,290. That sounds a lot more correct. Okay. But still 1,032, so that's 10. Oh, I should be doing that over 10. Okay, so this is wrong. 2. That should be that. That's important. Does that fix it? There we go. Okay, cool. It's very ugly. I need to change those colors, but yes, and we need to make it so that they stay fixed as I shift that. Fixed in the same size. So maybe I'm thinking about this the wrong way, but get around to that. Let's at least get a nicer color there. HTML color picker. We'll do like that, which is 64. What are we using right now? We're using 80. Is it really that big of a difference? It's always hard to like judge colors unless you're looking at it directly. Yeah, see, like that's still bright. Like relatively, so here, that looks way darker because I'm looking at it on a white background. But then here, it looks really bright because I'm looking at it based off of that dark background. Okay, let's go like 32. It's a nice power of 2. Let's see how that looks. Yeah, that's almost the same color as this. I should probably just be using that color, whatever it is. And then I kind of want these offset the other way. So instead of doing that, we'll say I is 1. That way we kind of get it offset the opposite direction. Yeah, there we go. That's better. Cool. So, and maybe we'll have these more granular. I don't know quite. I wish I had left DaVinci Resolve open. Let's just take a peek at their UI and see how they make it look. Images. Okay, so they just have like lines. Maybe I'm thinking about this too much. Yeah, they just got lines and like just borders. Okay, so maybe that's a better idea, is we just have like fixed lines to denote some passage of time instead of this. I don't know though. Maybe this will be nice. Who knows? I mean, we can still use this code, and then instead of add rect filled, I can just say add rect. And that should be the same thing. Hopefully. Yes. Cool. The width, we would probably have to change those because that's very faint. Or we could probably increase these to 64. Probably be a good idea for me to like mock this out in Inkscape or something so I know exactly what I'm going for and then code it, but that's not how we do things. Okay. Rect start plus square width. Let's just increase that stroke width. Can I do that? Yeah, thickness. Okay, we'll say rounding is 0, flags is 0, thickness we'll do like 3. Just so that we can see those lines a little bit better. That's a little bit too better, I guess. Yeah, ideally I'd just draw vertical lines, which I might change it to. I don't know. We could do float line width equals 3. This is what we'll do. We'll say add rect filled, rect start, start plus line width. Well, actually, we'll do this half line width equals 1.5. Yeah, and then what we'll have this is minus ImVec2 line width canvas, I guess 0. That's 0. We'll do something like this, which should give us better, more consistent lines. Okay, so that should just give us a line on the first, and then we can add a line on the second half too. Yeah, because these are still kind of off. So instead, what we can do is like, we'll do the same thing, except we will go plus, actually we can leave that and we can just do plus ImVec2 square width. And same thing here. And that should give us a consistent, yeah, okay, cool. Now we've got our lines. That's good. And now 64 is once again too bright. Let's go back down to 32 and see how that looks. Cool, okay, I kind of like that. Yeah, so much layouting stuff. Yeah, I know. There's probably so many ways that I can make this easier on myself if I just used like the stuff that ImGui already has, but I don't know what ImGui already has, and so it's just easier for me to just do it this way, you know? And then I can have explicit control. I know exactly how it works. I don't have to worry about any magical stuff and all that, everything. Let's get the thingy, the cursor, which is a triangle and the thing. Okay. I'm getting tired, as you can see. I want to get that though, because I want to be able to move it around, which is our current frame, right? First frame, current frame. Okay. So what we'll do is for now, we'll just have that timeline be like the entire length. And this first frame, current frame. Yeah. How do we want to do this? Because we also need like how many frames are currently there. Like what's visible. So let's do this too. Int number frames, right? How many frames are there? And we will take that in right there. Where's that? That's right before that. Int number frames. Okay. So what we'll do is our frame will normalize this value, which is what? Our first frame, our current frame. Okay, so we'll normalize that. Float frame pose equals current frame over number frames. I swear I just had that. Number frames, yeah. Num frames. Why doesn't it like this? Is undefined. It is not undefined. It is defined right there. No, it's not. That's the wrong function. Okay. This is the one I meant to do it in. That makes more sense. Cool. So what is this? Do star. Cast it to a float. Float. Okay. So we got that. Normalize frame position. And then we want to draw like a red cursor there. So I guess we do like our ImVec2 cursor start equals canvas pose plus legend size dot x. Zero, right? So we'll have it there. And then I guess we will just add a normalized value, yeah, from the rest of the width that's left. So canvas size dot x minus, or yes, minus one, no, times 1.0 minus legend size width. So that gives us the rest of the width that we have left, and then we can just say frame pose times that, which gives us our frames position, frame offset, or cursor offset. Okay, and I guess we'll just do that, float x. Okay, so then for now we'll just say draw list, add rect filled. Pmin is gonna be our cursor start. Yeah, and then we'll have our, well, I guess we want to do cursor start. Okay, so we want to do this, which is here, cursor start plus that, plus, I guess we could just do this plus cursor offset. Okay, so that should give us that, and then we can just say draw list, add rect filled, and this will be our cursor start, and then our cursor start plus cursor size, and we'll do color is going to be some sort of red color, so we'll get that in a minute. Cursor color, and then we will have nothing else. Okay, cool. So we got that. Our cursor size is going to be ImVec2. We'll just do like 4 pixels, maybe 3 pixels, since maybe like 3.5 pixels. So 3.5 by our canvas size.y. And then we'll add like a little triangle thing at the top and all that good stuff eventually. Let's get a red color real quickly. So this is like my go-to. And they have it on a nice red already. Kind of like that. Let's go. I like the pastels though. Let's try this out. So 214, 118, 11. Let's see what that looks like. Okay, we got that. Our cursor color, we're gonna have that. Let's see how that looks. Uh-oh. Number of frames. How many frames do we have? We've got like 12 seconds here times 60 frames per second. Okay, that's that. Yes, that's that. Cool. Okay, cool. Yeah, I do like this. That's a pretty good color too. It's not at the beginning though, which is interesting. We should have it. Oh no, it's not at the beginning because I have first frame. I have current frame set to 100. Okay, cool. So this is good too. It kind of tests that. Now, if we move it, it should change the current frame. So let's do that real quickly. Thanks. Yeah. And we're getting really close now. I normally do 0.8, 0.2, 0.3, and it looks pretty good. Oh, for reds. You don't like the OSX color meter thing? I've never heard of this. OSX color meter. What is this? Huh. I don't have Apple, so I couldn't use this if I wanted to. But if I did have Apple, that sounds like it'd be a nice little tool to be able to use. Okay, so let's see. We've got our cursor start here. We want to then check and see if they are hovering over it, right? So and I guess we'll do something similar to like what the whole thing was. Ooh, and this is basically the same exact logic. And this is where it would be really nice if I actually knew how ImGui's functions worked. Unfortunately, I don't. So we're just going to copy stuff. So, okay, we'll do this. Sorry, I didn't know. You're all good. Handle cursor. That's what we're going to call it. Handle cursor. Canvas pose, canvas size, legend size. I guess we'll just keep all that stuff, right? That all works. And then we want, instead of legend width, we want cursor pose, right? Whoops. Let's get Gabe a Mac. And I was actually surprised because at my work, I was really expecting to get a Mac because that's like the de facto thing in most corporate jobs. And then they gave me a Dell and I was like, I'll take it. And then when I got into work on my first day, everyone was like, the heck, why do you have a Windows, like, why do you have a PC and not a Mac? And I was like, I don't know, they just gave it to me. And it's like, I didn't complain. I was like, I'll take it. And of course, that meant that like setting up the dev environment, everything sucked because nobody had Windows support. So I basically just had to do everything on myself, which, you know, excuse to mess around with stuff, but good times, good times. Okay, anyways, though. So if we're hovering the rect, we want to do this. This isn't splitter anymore. This is our whatever, right? This is our cursor now, right? Yeah, cursor. So let's call it cursor. Cursor begin, cursor width. And what did I say that was? I said that was something like this. Let's go ahead. We're just going to grab all this stuff real quickly because I actually kind of need this. Okay. And we're going to use this stuff instead. So current frame is something we need, which we're going to pass through here. I guess we'll say int star current frame and int number frames, right? So we'll pass those things through. Legend width, which we can pass through here. Do we really need that legend width? I don't know. Dude, you got a Dell. Yeah, Linux can be harder. I've seen the support channel at my work. That is true. Sometimes I had to just switch to like an Ubuntu because like, I don't know, at least with Linux and Mac, you still have like sort of the same bash kind of terminal type stuff. Whereas Windows is just like, you know, have fun. They have gotten better though in recent times. Windows has a little bit, not great, but a little bit. Let's just pass that through too. Legend width. Okay, so we've got the cursor size, we've got the cursor start. We want to draw it, right? Okay, so this is basically everything we need. So now I just need to swap this stuff out. So then if we're hovering over the cursor, which is our cursor start, and I guess it's this would be the end. Hover width, let's call that hover width. And then we'll do like const expr float hover width equals, our cursor size is 3.5. So we'll do the hover width as like 6 pixels. That sounds good to me. I don't know. Okay, so if we are hovering that rect, don't need that. I've already got that stuff. Add rect filled, splitter begin. Okay, so this is where we basically do this stuff, right? Except we want to do the hovered version. Right, okay, so I guess basically what we want to do is like, if is hovering and not is active, we want to do our hovered, else if is active, we want to do our active, else we just want to do our regular, and then we will have like, and I guess this is all kind of, yeah, we don't really need any of that too. We just need that, and then we need like the cursor color. Yeah, so we'll have the, okay, this is done like 5 different things here. So we'll do cursor color, right? If we're hovering, we set that cursor color to something else, right? So then we say cursor color equals this, and this will be our hover color. And then if we're active, which I guess we should do down here, right? If we're active, then we do our active color. Cursor color equals that. Okay, and so let's go here. So hover, we want to go a little bit brighter. That just lagged horribly. We'll see how that looks. So 237, whatever that was, paste that there. And then for the other one, we want to go slightly darker. Well, man, why is this lagging so bad? Okay. I guess I can't grab the actual handle. That's weird. Okay, so we'll do that for active. Kind of like a bright, but just a different bright. 255. And at the end, we draw it, because we just draw it regardless. We just need to know what color to draw it as. And then if we are hovering, it sets the mouse cursor to this. Cool. I guess we want to do this if it's hovering or if it's active. Yeah. Wait a second, let me, oh, I can't do this yet. I was just gonna say, let me try something, but we can't try it yet. Okay, anyways, let's just keep going. So that's all good. Okay, if we're clicking down. So, okay, so this is where we actually need to change it. We need to change our current frame plus equals the drag distance over the canvas size dot x. We want to normalize that drag distance. No, we don't want to do it over canvas size. We want to do it over the number of frames possible. Yeah, that's what we're gonna do. So I guess what we'll do is we'll say over number of frames, do float, and then we'll do a glm floor, and we'll cast that to an int. Okay, and then we just want to clamp that. So we want to say glm min, glm max. We can't go past number of frames -1. That is the max. And for the min, we want to make sure we don't go below 0. And this is our current frame. Okay, so I guess max 0, and then, yeah, that. Cool, so that should give us what we want, I think. Copy that. Copy that. Paste. And now we can say if handle cursor. If handle cursor, canvas pose, canvas size, legend width, current frame, number of frames. Okay, we do whatever we do. Yeah, I guess we can get rid of all that. Result equals true. We've changed something. We've changed that guy. The current frame. Let's just see if this works. If we can drag it left and right, that's cool. Okay. I did go left. It's not going right though. Why are we not going right? Float drag distance over number of frames. Max 0. Min number of frames or this. Maybe we should do seal. Okay, that's working. I really don't like that weird, it just doesn't go the right distance, I guess. I guess we can just do like plus equals whatever our drag distance was, honestly. Is this even, yeah, no, that's a float. Okay, whatever. Yeah, let's just do that. Let's see how that works, how it feels. Yeah, see, that's why I didn't want to do this, because it kind of messes up. I guess what we can do, we don't even need to get the drag distance. We can just set it to wherever our mouse is. Let's do that. Mouse pose. So let's get the IO dot mouse pose dot x. That. And then what we can do is we can say float normalized pose x equals mouse pose x over the length of our track, which I guess is just 1 minus that times that x. So 1 minus times canvas size dot x, right? Okay, we did a calculation like this, very similar. Right, so we just do mouse pose over that, and this doesn't really matter because multiplication is commutative, division, but we're doing it. So x over 1 minus that times that, yep, that's our normalized position. And then what do we want to do? We want to set it to times number of frames, right? Yeah. And then we want to do that parenthesized. And let's see if that works. So it should just set it to wherever our mouse is. That didn't work. Nope. Okay, so I think I'm not using the screen position, which is something that we were warned that we should do. Content region, get cursor screen pose. I'm close here. We're almost there. What am I doing wrong? I think this isn't actually normalizing it properly. So if I go and then I do that, normalized position is 1.3. Yeah, that's definitely not right. Okay, so mouse position is 1373. Our canvas size is, oh, we want to do mouse pose minus the canvas start. That's why. We'll do that minus canvas position, and that should be what we need. Okay. Still not right. I think that was closer this time. Maybe, I don't know. We will go put that there again. Okay. That, did I get it? Normalized mouse pose is 0.3. Okay, so that sounds right. Okay, mouse position 1374, 70. So we have 720 frames. Oh, I'm doing plus equals. We just want to do equals. That's why it was zooming away. Okay. Now we should be good. Promise. Okay. Sort of. And I also need to make sure that it doesn't trigger that. Oh, I'm doing minus the canvas position. We need to do minus the legends start. So I guess we also need to subtract size there. Okay, now we should be good. Nope, that was the wrong direction. What happened there? Okay. Oh, that's the canvas size. I want to do the legend size. There we go. This is the last time, I promise. There we go. Okay, now we can go, and you can see it's actually changing there too. If we make this a little bit bigger, it says 334 there. If I grab this and move it over, we're moving down and up. Thank you. That's what I wanted. That was way harder than it needed to be. We also need to fix it though, because if I move over here, then it drags onto that too. Side effects of programming late at night. It is true. I think the streaming is the extra addition, because usually, you know, you can program late at night and be pretty good for a while. Sometimes, I don't know. Sometimes it gets bad. Sometimes I'll catch myself and I'm like, why am I adding this? I don't know. And then I'm like, I need to go to bed. But we're almost there. I just want to get the last portion in, which is, let's use this frame to actually affect where our timeline is here. Okay, that's the last thing I want to do. So what we can do is we can, the way I have this all set up inside of my application, if we go into application.cpp, okay, right in here, we've got this time accumulation thing, right? And time accumulation is in increments of 1/60th of a second, which is one frame. So if I give ourselves an API to say void set frame index int frame, then what we can do is we can actually go here. We can just say time accumulation, which I need to make a public variable now. Well, public private. So we have that here. Let's move that up into here. Okay, so time accumulation is this frame over 60. No, frame times 60. No, frame over 60. Yeah. Equals float frame over 60. Okay. And then inside of timeline, every time we do this, we'll say hash include core/application. And actually, I want to put that down here. This is like a separate thing. Okay. And if we change this, if that gets modified, I guess this would be good to break up into like increments so that you know what's changing, because right now you don't know if it's the current frame or the first frame or what's changing here. But we'll just do it this way. Anyways, we can say application current frame or set frame index current frame. Okay, so then we should be able to set it to that. And let's just make sure that we're actually returning true when it gets updated, which is, where did we have that? Timeline GUI, timeline GUI. Somewhere in here. ImGui timeline. Yeah, it disappeared. Okay, so we actually, yeah, so if we handle the cursor, I do say result is true. Cool. So this should just work then. So, fingers crossed, these should be hooked up now, but it's not. I already, well, look at that, guys. Look at that. I can control where we are inside of our animation by clicking here and dragging left and right. Okay, so, you know, we're getting places. This is something. So at the most basic form, we at least can go back and forth through a timeline, which isn't that great, I guess, but yeah. Oh, and I guess something else that would be nice is if we actually change that to as it plays, because right now we're not actually grabbing that value. But yeah, that's pretty cool. We can actually do that pretty easily too. Let's do that real quickly. So if I go application H, we can actually say void get frame index. And what we can do here is we can just say return frame times 60. And we'll just cast that to an int. I guess that's a time accumulation, right? So if we want to get the frame, we just multiply that up. Yeah, that's good. So we do time accumulation. This should be int. That should be int. And then what we can do is say timeline, or actually I guess inside of here, this timeline. Instead of making this static and changing this every time, what we can do is we can say that equals application get frame index, right? Then if it changes, we're still setting it, so we can still modify it, but we should be able to see the timeline editor actually move as that changes too. So yeah, it reset to 0. And if I hit play, okay, cool, yeah. And if I hit play, we can see it start to move down there. This is pretty cool. I am happy with this, you know? And it is getting kind of late here, so I think I'm probably going to stop it here. But this is solid progress, I think. Next up, I just got to actually get these animation objects working and stuff and hopefully get this in a better state. But thank you all for coming. I'm glad you guys could make it. Kind of impromptu stream. I probably will not be streaming this. I definitely will not be streaming this Saturday. I've got other plans, but it was good to see you guys still. And hopefully I'll see you next time. And hopefully I can release this for you guys to use too if you ever want to. Who knows? It's open source. Check it out. It's on GitHub if you want. I don't care. Anyways, guys, I will see you guys next time. Hell, okay. See you guys.